The learning targets for this lesson are: I can describe a rotation, I can rotate a figure 90 degrees clockwise, I can rotate a figure 90 degrees counterclockwise, and I can rotate a figure 180 degrees. Here are some pictures that describe a rotation. A rotation is just a turning of an object. So I think of a globe turning or tires turning. Funny comic says, don't bother rotating the tires. They rotated on their own all the way here. So again, a rotation, when you think of rotating the tires, it's just turning of an object. So the T's in rotation remind me that it's a turning of a figure. And regardless of how I turn a figure, it is the same size and the same shape, which is congruent figures. The exact same figures that are produced in a reflection and a translation, they're all congruent. The only figures that change size are a dilation, which is a different size but the same shape, which is a similar figure. So we're going to start out by looking at how to rotate a triangle. So if I had a picture of a triangle and I wanted to rotate it 90 degrees, our turns are in 90 degrees, so I would just turn it one time to the right, which is clockwise, just like a clock. If I had the same arrow and I wanted to rotate it 90 degrees counterclockwise, I would go one time to the left. Okay? If I wanted to look at 180 degrees clockwise, I would go 90 degrees clockwise and then another 90 degrees clockwise for a total of 180. Last example we're going to look at is 180 degrees counterclockwise. So again, I go one time to the left, which is 90 degrees, and then another time to the left, which is 90 degrees for a total of 180. As you can see, the clockwise and the counterclockwise for 180 are the exact same. It's always turning a figure upside down, so it does not matter if we go left or right or clockwise or counterclockwise. The only time that does matter is for 90 degrees. Okay, 180, you can go to the right or to the left. Okay, so this is an example. First thing I want you to notice is it says draw the image under a rotation of 90 degrees clockwise and give the coordinates. So it's really important to write your name on the top of your paper. If you notice here, this is the first time we've not had numbers on our axes, and that's really important in a rotation because we're going to be turning the paper and the numbers are going to change. So it says turn your paper one time to the right, 90 degrees clockwise. So I'm going to turn my figure, you're going to turn your entire paper one time to the right. So we're going to pretend that we're looking at a new set of axes. So this is the top of my paper now. We're going to pretend, and the triangle is now in quadrant 4. So the first thing we do is we write down our coordinates of the new triangle. So M is 9 times to the right and 2 down. So it's 9, negative 2. A is 1 time to the right and 2 down. So it's 1 time to the right, 2 down. And T is 1 time to the right and 8 down. Okay, now it says turn your paper back to the original way. Okay, that's why it's important to have your name on top of the paper. Okay, plot your new figure and label. So now we're just going to plot our new coordinates. So M is over 9 down 2. A is over 1 down 2. And T is over 1 down 8. And once we connect our points, we now see we have the exact same triangle. All it did was turn into a different quadrant. So that's an example of a 90 degrees clockwise rotation. Now we're going to look at the same exact triangle, but now it says we're going to draw the image under 90 degrees counterclockwise rotation. Okay, so again, name on top of the paper. There are no coordinates written, no numbers written on the axes. And we're going to turn our paper. So turn your paper one time to the left. And we're going to pretend we're looking at a new set of axes. So if we're looking at this, our triangle is now in quadrant 2. So we're going to write down the coordinates of this new triangle. So M is now 9 to the left and 2 up. So 9 to the left, 2 up. We have A prime, which is 1 to the left and 2 up. And we have T, which is 1 to the left and 8 up. That's why it's really important to know how to name coordinates. Okay. Number 4 says turn your paper back to the original way. So your name is on the top. We're going to plot our figure and label. So we have M as left 9 up 2. We have A as left 1 up 2. And we have T as left 1 up 8. Okay. So if we connect our points, we're going to see we have the exact same size triangle, just turned 90 degrees clockwise, counterclockwise to the left. Okay, last example we're going to look at is the exact same triangle, name on top of the paper. We are going to turn 2 times. Now it does not matter if I turn 2 times to the right, which is clockwise, it would end up in quadrant 3, or 2 times to the left, it ends up in quadrant 3. So 180 degrees, 2 times, does not matter left or right. We're going to pretend we're looking at a new set of axes. Again, the triangle is in quadrant 3, and we're going to write down the new coordinates. So M is left 2, down 9. A, really important to look at the correct letter, is left 2, down 1. And T is left 8, down 1. Okay, we're going to turn our paper back to the original way, so your name is on top. Last thing we're going to do is plot our new coordinates and label. So we have M, left 2, down 9. A is left 2, down 1. And T is left 8, down 1. And once we connect our points, we have a 180-degree turn of a triangle. Okay, so the last thing I want to mention is that the most important thing is to make sure once you're turning your paper is that these coordinates are correct before you turn them back to plot. M becomes M prime, really important to name that coordinate correctly. Again, 90-degree counterclockwise, these coordinates are the most important. You have to name them correctly and plot them correctly to be able to correctly plot a turning of a figure.